In this video, I would like to finish off the systems of equations and inequalities by graphing some compound inequalities. So I'm just doing a bunch of examples and I'll explain as I go along. This is typically what you'll be given. We would have to graph y is less than x plus 4 and y is greater than or equal to -1. And over here somewhere they might have the word and. So that means both of them together. You graph each of them kind of independent of each other and then see what regions overlap. I'll show you what I'm talking about. For this thing, let's draw in here not the math, in shapes. Let's go and do this guy right here. And typically they do try to conform to the grids I have up there. Gotcha. Let me close math. Let's start with y is less than x plus 4. Recall that if you were to graph y equals x plus 4, you would have a y-intercept of 4. So let me put a dot there. And then the slope in front of x is 1. So you're going to go up 1 and to the right 1. And you can continue that method. What I'm going to do, I'm going to try to make use of this ruler and see if I can get it just to where I want it. And it's hard to do, but I'll see if I can. Oh, you can't do it one-handed. Okay. It is tricky, I'll tell you. That looks all right. Now, remember, since it's less than and not less than or equal to, I'm going to do dashed lines. And let me put the ruler away. I think that's good enough. Now what I want to do is I want to shade underneath of it because y is less than that. Remember, you have an upper and a lower half. I want the lower half to be shaded. So what I do is I typically will do something like this. The way I shade is I want to shade one direction. You'll see what I mean when I'm done here. And I will do this, and I'm purposefully taking a lot of time here. I want you to get this right. So what I'm doing is I'm shading underneath of the line because y was less than that. So I'm using these markings as my shading. And I made a mistake there. You need to go all the way to the drawn line. So let me fix that a little bit. Well, it's a tough little ruler, I'll tell you. Sometimes it has dead zones, so we'll see what I can get away with here. There we go. Hopefully you'll have yours finished much faster than I'll have mine. But the effect that I'm going to make is very important. You'll see what I'm talking about. I think one more and I'll be happy with my shading. Oh, it looks like that's as far as it's going to let me go. I can move that up. All right, we'll do that. That thing's a double. Okay. Gotcha. Now let's do the other line. Y equals 1 or y equals -1 is a horizontal line. And in fact, let me put it in here, -1. And there it is right there. So what I'm going to do is y equals -1. Let me draw it, but let me make it thicker, in fact. So I can come to my pen, and I'm going to make a thicker, fatter line for just that. And let me put the ruler away. That line there is y equals 1. So let me go back to my regular size. Y equals 1. That's still fatter than I want it to be. There. Okay. So we need to be greater than or equal to -1. That means from here we draw lines, but I'm going to draw them vertically here, and you'll see why in a minute. Let me grab my ruler back, and now let me twist it. And starting from here, I'm going to draw just vertical lines. Until I get to it. So it's a good thing I made it thicker so I would be able to see it versus the other one. Of course, I need to make room for my writing. And make sure when you do these, just go till you get to the line, because you're interested in greater than or equal. And the line is solid, so we know that the points on the line are part of the solution. This is when you'll start to be able to see what I'm talking about here. If I keep going, starting and going down to my line, down. That one was already there. You can see the region that I'm talking about because it has markings going horizontally and going vertically, so it's easy to see where the solution to this thing is. I'll go ahead and stop there because I think it's obvious. This region here, bounded by this line, this dashed line, right? The line itself doesn't have solutions, but there are solutions underneath of that. We knew that. And then I've got solutions above this line. That's the greater than or equal to, and it's a solid line. So let me go ahead and shade in the area then. So I think with that, let's say that we can do a highlighter, and I don't know about yellow. Let's do red. We'll see how good or bad that looks. And so this is the region I'm talking about here. I guess if I want to be super duper accurate about it, and I do like that aspect of it, let me go ahead and put my ruler here. And right along that edge there. Beautiful, nice. And then let me get the ruler down here. And shade above that area. And then I can just shade in between. You can see, I'm sure there's a painting method you could do here. Here's like painting that I'm doing if I really want to shade it in a lot. But this, you can tell, all of these points that are in here are answers. I'll show you one in a minute. We'll grab one at random and I'll show you that it works. So in all of this, I did forget where my X and Y axes were. You do not have to do all this. All you got to do is the double hatching. Well, you'll do it on computer, so it'll have its own method of shading, and I'll probably do one out of there too if I can, depending on how long the video goes. All right, so I think I've got enough of this shading, and you can kind of tell. Now let me get rid of this ruler again. Let me go. Let's check a point, just a point at random, and I don't know. Let's grab something over here as a checkpoint. That point there, if I remember, where was the x and y axis? This was the x-axis. And good question. I don't know where the y-axis. This must be the y-axis right here. Okay, so what is that point? That point for the x is 1, 2, 3, 4, 5, 6. And for the y, it is 1, 2, 3. It is 3 for y. So we have the point 6, 3. Let's see if it's actually a solution. So I'm going to do a little check down here and see if the 6, 3 actually works. So when x is 6, y is 3. So we have y is less than x plus 4. Let me put in the 6 for x and the 3 for y. 3 is in fact less than 10, so that checks. And now the other one was y is greater than or equal to negative 1. And y was equal to 3. So that checks. As long as they both check, you know that you have the solution. So that's what this is about here. We're going to be graphing these systems of inequalities. And just keep in mind where the region is you shade and whether you need dashed or solid lines. Let me do some more examples. As always, excuse my kids, they cannot be quiet. So let's see, graph. Here I have x is less than 3. On the other hand, I have y is greater than 2/3 x plus 1. So both of these are dashed lines. Let me go ahead and get a graph in here. I'll give myself more space than I did last time. I felt like I was a little bit cramped then. So that looks pretty good. All right, let's start with x is less than 3. Remember, x equals 3 is a vertical line. So if I go to 1, 2, 3, I'll have a vertical line, but since it's less than, I'm going to have dashes. So let me grab my ruler. I don't know if this can be controlled any other way than by my hands, but I'm going to try and see if I can get myself a good dashed line there. And all right, now what does it mean for it to be less than 3? We want all of our x values to be less than 3. That means I shade the entire region to the left of this line. So let me go ahead and do that. Vertical lines would be weird considering my boundary is a vertical line. So I'm going to do horizontal lines for my shading. So my shading only goes up to there. I suppose you could try multiple colors. That might be reasonable. I'm not really sure. But I think this system works really well because it's easy to see the overlap. But let me keep continuing to get my lines. And this ruler does get easier to work with once you are practicing with it. And one thing, since last time it disappeared from me, let me put my y and x axes so I don't forget those. So all of these points that I'm shading right now have x values that are less than 3. All right, that's about as far as I go. I think that's good enough. Now for the other line, y is greater than 2/3 x plus 1. Let me graph the 2/3 x plus 1. So what does that mean? The y-intercept is at 1, so that's this point right here. and then 2/3 we go up to and to the right 3. So let me do that. Up to and to the right 3. Up to and to the right 3. So I do this for a little while just to give myself more accuracy. I'll even reverse myself by going down 2 and then to the left 3. Down 2 and then to the left 3. Down 2 and then to the left 3. And it stuck it on the ruler, which I did not intend. Alright, so let's get this ruler in place. Now what I want to do here, since x is greater than and not greater than or equal, I hope that's good enough. All right, let's go ahead and put my dashed line for here. I should probably use thicker lines just so it stands out. But nonetheless, notice it says y is greater than that. So when you look at this thing, we have an upper side of the line that's up here, and then we have a lower side of the line that's down here. I'm going to choose the upper side since y is greater than that. So what I'm going to do is I'm going to draw vertical markings coming up over that line, and then you'll be able to see where the intersection occurs. Better yet, I should probably say the overlap is probably a better terminology. So all I'm doing here, I'm trying to ignore the presence of the other stuff and just trying to focus myself on drawing this line until I get to my dashed line. So I'll stop there. See that? Try again. Start up here. Stop. So I think my next one I'm going to make fatter lines. Stop. 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 The dashed line, I won't mess with that. But then beyond, stop. 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 I don't think I need to go any farther. You think you can see the overlap from here. It's this region right here bounded by these dashed lines. So let me go ahead and get my colors in place. We'll start with, oh, there's the highlighter right there. Can I choose, let's choose the fattest amount I can, and let's see how that works. So if I go and do it, that's nice. Let me get my outline first. That is the one thing that I do want to get in place first, is my outline. And then I'll shade around it. Very nice. I see that if I do these ones, it's fatter if I go sideways than if I go vertically. Okay, well, whatever. I don't want to mess with my, I'm afraid to put white there for overlapping. It's like when you're a kid and you're trying to stay within the lines. I always had a hard time with that as a kid myself, so it doesn't surprise me that I'm not very good at it now. Anyways, let's go ahead and get all this region shaded. And there we go. So there is another answer here. The important thing is that we've got our dashed lines, because both of these inequalities are what they call strict. They're not greater than or equal. There's no or equal part of either one of these. And somewhat same as this. So any points that are on these lines is not an answer. Now, let me go ahead and check myself. Let me grab a point at random in the region of correct, what I think is the correct region. So for this, let me find out where my x and y values. I put a dot there, So the origin is right here. If I go to the left, 1, 2, 3, 4, 5, 6. Oh, okay. We got -6. And then for y, I go up 1, 2. It looks like -6, 2. Let me see if -6, 2 works for all of these things. Let me get my ruler out of the way. Let's check to see if -6, 2 is a solution. Then I'll feel really good about my region that I have shaded. So first, start with, is x less than 3? Well, -6 is definitely less than 3. Got that. Now, on the other hand, we had y is greater than 2/3 x plus 1. So let me put my numbers in there. Y would have been 2. 2/3 times -6 plus 1. We get 2. The -6 and the 3 cancel. We get 2 is greater than -4 plus 1. 2 is greater than -3. That checks as well. So I feel pretty good about the region that I have shaded. Let's try a more complicated example. We have 5x minus 3y is greater than 9, and then 2x plus 3y is less than or equal to 12. What I'm going to do before I do any graphing is I'm going to convert these to slope-intercept form. So this first one, the first thing I would do is subtract 5x. And then what I would do is divide by -3. But when you divide by -3, just remember to change the inequality. So for that one, I get 5/3 x minus 3. Y is less than that. Notice that the inequality symbol, let me see if I can get my mouse pointer on it. See it there? It's pointing to the right, and now it's pointing to the left. That's because at this stage, I divided by -3. -5 divided by -3 gave me the 5/3. 9 divided by -3 gave me the -3. I'll do the same thing on the other one. First thing I'll do is subtract 2x. So I have less than or equal to -2x plus 12. And then this time I don't have to change the inequality symbols when I divide by 3 because it's a positive number. I'll get -2/3 x plus 4. So these are the ones, I'm actually going to use these for graphing instead of the ones given to me. It's a lot easier to graph when you have it in slope-intercept form. Now, let me see if I can grab a shape go ahead and make it nice and big. Now, I don't know, but I'm going to see if I can make those thicker. Oh, you know what? There is a way. Let me do this. I guess not. Cut, copy, paste, delete, group. None of these are going to do anything for me. So I don't know if any of these. Oh yeah, okay, there we go. That's exactly what I wanted. All right, so we'll stop there. Let me go ahead and, because I keep forgetting later on, I'm going to call this X, and then I'm going to call this Y. So let's start with the first one here. Pretend you're graphing 5/3 x minus 3. So what you would do is you would put a dot at -3 for Y, and then from there you would go up 5 and down, up 5 and to the right 3. So let me do that. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. I'm not going to get a lot of these dots in here. 1, 2, 3, 4, 5. 1, 2, 3. I think there it is. Let me call on my ruler. Since it's less than a strict inequality, these will be dashed lines. Or this will be a dashed line. Almost had it. We'll go with that. Not as perfect as I would like it to be, but this ruler is tougher to work than a regular real ruler. Alright, so I've got that one. Now for the second one, we have negative 2/3 x plus 4. So let me go ahead and put a mark at 4. 1, 2, 3, 4. Oh, bad on me. Bad mistake. I should put my shading before I do the next line. So let me shade here. It says y needs to be less than that. So I'm going to shade below. Now what I think I'll do this time to make things easier to see is I'm going to go and make thin lines, and we'll see if that makes things easier to understand. So all these lines I'm going to do until I get up to the dashed line. This is my shading underneath. Alright, I've got my shading in. Hopefully it looks less obtrusive than it was before. Now I will go and graph the second one. It's going to be a solid line since y is less than or equal to whatever I'm going to put here. So I put my dot at 4, and now I've got to do negative 2/3 for the slope. So I go down to 1, 2, and then to the right 3. And I'll put a dot. Down 2, and then to the right 3, and I'll put a dot. Oh, I forgot. I have to make my thing thicker this time when I come back. So down 2, 1, 2, to the right 3. And those dots are a little heavy, but let's reverse my stuff. So up 2 and then to the left 3. And let me go ahead and do my ruler. It's going to be a solid line. Good. A little thicker than the other one, but no big deal. Now from that one, since it's less than or equal to, come back here. Since it's less than or equal to, I'm going to shade below it. But this time I'm going to use the horizontal markings. So I think for that I chose the thinnest possible choice. And let me go ahead and do this. So I need to stay underneath of it since it's less than or equal to. So I'll draw my thin horizontal lines this way. Remember to stop when you get to the line. Oh, I think I did a little too much for that one. So when you're sketching these lines, when you're shading, try to ignore the existence of the other line because it can get in the way. So like when I get to this double area here, I still got to make sure that I go up to my line. And you only need to do enough of this until you are sure you can see the region that needs to be shaded. Now let's see what we've got then. I can clearly see the area. If I had drawn more lines, I would have more crossings down here, so it would be easy to tell. But you can see right in here is the region that we need to shade. So give me my ruler back and let me do some shading there. Oh, it's a little bit off. Good. All right, probably then let me grab this highlighter and let's see how it looks. Oops, I didn't want that. I went down here. And let me turn it the other way. There's the boundary, and then I can go ahead and paint it like I normally do. And as always, I'm going to try a test point just to make sure that I have shaded the correct region. So let's move this thing out of the way. Let's do a checkpoint. Let me see how big my thing is. Let me make it about, I think there is a good spot. I'm going to pick one at random in the cross area. So let's pick this one. So let me see what my x value is. I go to the right 1, 2, 3, 4. So the x part of it is 4. The y part of it then is down 1, 2, just down 2. So 4, -2. And once again, I think I chose too fat of a marker for regular writing. So let me go to that one and see how it works. So let's do my check over here. We're going to check the point 4, -2, and I want to make sure it satisfies both inequalities. And if you really want to make sure that you're doing it right, throw them into the original inequalities. So I'll start with the first one. The 5x minus 3y is greater than 9. So let me put my numbers in. I'll have 5 times 4 minus 3 times -2 is greater than 9. 5 times 4 is 20. -3 times -2 is +6. And yes, you can see that 26 is bigger than 9. And then for the second half, the 2x plus 3y, that was supposed to be less than or equal to 12. Let me throw in my numbers. I have 2 times 4 plus 3 times -2, supposed to be less than or equal to 12. 2 times 4 is 8. 3 times -2 is -6. And that is definitely true. 2 is less than or equal to 12. So both of them check out, and I feel pretty good about my checkpoint. Well, not just the checkpoint. I feel pretty good about my solution. The next one is a bit of an odd one. A very, very strange type of a problem. And it goes like this. Graph x is less than or equal to 6 and y is greater than 1. So let me get my axes in here for this. What I do want to do also is give myself full room, because these axes, well now, look at that. That was pretty slick. Let me move it out of my way. I think that'll be good enough. Let me make it a little bit thicker. I think that was pretty good. And then we'll call this the x-axis and the y-axis. Very fat. Now, x equals 6 is a vertical line. So we go over 1, 2, 3, 4, 5, 6. Let me go ahead and throw my ruler there. And since it's less than or equal to, this is a solid line. That looks pretty good, especially with my big fat line. Now we're going to, since x has to be less than or equal to 6, we're going to mark off to the left, because the value, the x coordinates of these points to the left will all be less than or equal to 6. So this time let me go ahead and make my lines very thin. And let's go ahead and grab this ruler. And when I mark my lines, I'm only going to go up to that vertical line. Oops. I think that hopefully that's good enough. Now on the other hand, we have y is greater than 1. So let me go ahead and make my lines thick again. Y equals 1 is a horizontal line. Here is 1 right here. So let me draw this horizontal line. But since it's greater than 1, I'm going to put dashed. And what you want to do here, since y is greater than 1, you want the y values to be bigger than 1. So just draw above that particular line. Let me go and get my vertical lines now, and they're only going to go to that particular line. So let me go ahead and choose my appropriate pen for this task. And here we go. But now keep in mind, you're only going down to that line. The line y equals 1. So notice how I'm ignoring the other line for now, and I'm getting my complete graph in play. But I think this is far enough where you can see the region is this kind of rectangular region here. So let me bring my thing back and let me go ahead and put in my shading. Yeah, let's see if that'll work. So let me grab my shader, go down to there. Not exactly where that little bit is not what I wanted. So let me go ahead and do this. Stop there. Oh, look how bad that is. No, I don't think so. I need more shading here. Oh, not quite. Let Well, that's a little better. Okay, I can live with that. All right, so I've got that. Now let me go ahead and get this other one in. Same deal. Let me go ahead and shade across. Good. Now I'm ready to shade. I guess up and down is not so good as across. So I don't like how thin this border is. I'm afraid, just like regular painting, I'm afraid I'm going to go over it, like when I do my house, any room in my house. So this region here, as long as you understand that the region also is an unbounded region, it goes forever and ever. Let's go ahead and pick a point in there. Let's pick, this time I won't go so egregious. Hey, pick you. Now let's see if I can make it. Interesting. Looks like I've locked it up. Ah, there we go. All right, let's try my pen again. Good, this time it let me do it. All right, pick some point in the region. Maybe the easiest point is to pick something on here, on the y-axis. The x value is 1, 2, no, the x value is 0, sorry. The y value is 1, 2, 3, 4. So that's what I'm going to check. 0, 4. So let's start. Is 0 less than or equal to 6? Because the x part had to be less than or equal to 6. That checks. Now the y part is 4. Is 4 greater than 1? That's the y part. And y is 4. That checks. So I feel pretty good about the region in question. Boy, oh boy, we are stuck here. All right, let's see. Another example. This ruler does not want to go away now. Okay. What we have is x is greater than 2. Y is less than or equal to 7. And then you have one more, 3x plus 5y is greater than or equal to 15. So what I think, this is a bit weird because it's got 3 things this time. Let me fix this last line. I'll get 5y is greater than or equal to negative 3x plus 15. But then I'll divide by 5 and y will be greater than or equal to negative 3/5 x plus 3. So you got to make sure that that's a solid line. Well, you get the idea. You know where your solid lines should be and where they shouldn't be. So let's go ahead and start graphing this. And let me make it fatter. I think, did we do that one? Probably one more, just to be on the safe side. Yep. And then I can click out here. All right, I've got that in motion. Now let's see what we have. X is greater than 2, so let me go ahead and draw the line x equals 2, but it's going to be dashed because it says x is strictly greater than 2. So let me get my dashed lines in there. And then it says y is less than or equal to 7. 1, 2, 3, 4, 5, 6, 7. That's this. Let me go ahead and draw a solid line under that one. All right, if I need both of those to be true, then the region I'm interested in is this region over here. So what I'm going to do is, since I'm not going to try to find the region between just these first two, because we did that in the last problem and it was pretty simple. I know that the region that I want will be to the left of the dashed line and it will be below the other line. So what I'm going to do is I'm going to draw the shading where I know it's going to be at. So let me go ahead and put my shading in. And it goes all the way to the dashed line. My method has trouble when there's more than two lines in play. So I'm just making sure that my x values are less than or equal, or well, my x values, oh, look at this, I made a mistake. Here I am trying to convince you this. I wasn't paying attention. X greater than 2 means the x values are on to the right of that. So let me see if I can get rid of some of these lines here. I made a mistake. Let's bring this back. The region that I really wanted was to the right of that line. I don't know what made me think to the left. So let's go ahead and draw our lines from here. And notice all of these have x values that are greater than 2 and y values that are less than or equal to 7. The application of these graphs, unfortunately, we're not going to cover them in this class, but they will do, you'll use them for things like what they call linear programming and things of that nature. Now, let me go ahead and graph this line right here. It's a solid line because of the greater than or equal. Negative 3/5, the 3. Let me go ahead and go up 1, 2, 3. And there's my dot right there. And from there, I'm going to go down 3 and to the right 5. So down 3 and to the right 5. And put another dot. Of course, it's hard to see them with those things, with how fat these lines are. So I'll go down 3 again, and then go to the right 5. I think that's right. 1, 2, 3. 1, 2, 3, 4, 5. Good. And let me do one the other way. So I'll go up 3 and to the left 1, 2, 3, 4, 5, and put a dot there. Now this is supposed to be a solid line, so let me make that this way. And I'll do like my other lines. I'll make it nice and fat, so it's easy to see the border region. So I think that requires me to use that kind of a dot. Okay, I got my solid line. Probably could have been fatter, but nonetheless. What do I want to shade below it, or do I want to shade above it? According to this, greater than or equal to means I want to shade above that line. So that means all throughout the existence of the line, let me go and shade. I don't like it. It should move for me, but it's not. even though you've got the other markings there. This, try to make sure you go all the way down to the line that we're currently working with. I think by now you can kind of see the region that's in question. It's bounded by this line right here, this x equals, what was that, x was greater than 2, then you had this y less than or equal to, what was it? Y was less than or equal to 7. So let me go ahead and put my shading in. That's actually a little bit more than I wanted. So let's fix it. You only go up to that and then down to that. There we go. Now let me get the top part. Horizontal ones are a lot better than the vertical ones, that's for sure. And then down here, do we still have cross hatching all the way down here? Yes. I can fix that last one. Let me have my ruler back. Probably a better idea, instead of trying to draw a line like that, is just go like this. And then go ahead across. I did a little mistake there, but you get the idea. You know, these ways, I don't like this way at all. So let's see if we can get that. Okay, now let's check something to see if it's actually a solution. So I really don't care what. I don't know. I'll just pick a point out here. Let's see the x value. That was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for x. The y value was 1, 2, 3, 4, 5. So the first two are really easy to check. We have, look at the first inequality. Is x greater than 2? Well, yes, it's 11. Is y less than or equal to 7? Yes, it's 5. So both of those seem good to me. Let me check this last one, but I'll use the original inequality for that check. So the point that I'm checking is 11, 5, and I'm throwing it into 3x plus 5y greater than or equal to 15. So let me throw in my numbers. 3 times 11 plus 5 times 5 greater than or equal to 15. I think it's pretty obvious that it is. But in case you need completion, 33 plus 25 is 58. And there we go. So we get, this is basically the idea. I want to do one that's also on your homework. So let's go to Alex and grab one of these things and see how hard they are. There's one of my videos that was there before, but I am going to instead go to Alex. and take a look at one of your homework problems. So I will choose Math 0955. And we'll take a look at the latest assignment that I have. At the time of this writing, it's not due for a while, but when you get onto it, you'll want to see this for sure. So here it is, sections 5.4 and 9.3. Let me click into here and see if I can find myself an inequality. Most likely, I can find them near the end of the problem list, but we'll try. Okay, there's 19. All right, so this one might be perfect. All right, I just want to show you how it works. They've already got it in slope-intercept form. So what I want to do is I'll start with the first line, y is greater than or equal to 3x plus 7. The first thing I would do is put a 7 on the y-axis. So I'm not really sure. I think you can do this. And I can put my first point at 7. So there it is. Now for the second point, the 3 is the same as 3 over 1. So I'm going to come here and go up 3, 1, 2, 3, and then to the right 1. And when you do that, it'll put the line for you. So you can see that it's got the solid line where I want it. Now for the second one, now you've got to keep this in mind too. The region that's being shaded is above. Now I think you can do that right now. Like put it there, okay. Now let me do y is less than negative 3x minus 4. This time, I think I'm going to click on that before I do anything. I'll put the y-intercept, which is at negative 4. And then it says down 3 and to the right 1. So let me go back to that point. This thing jumps all over. Go down 3 and to the right 1 and put another point. That line needs to be dashed. Got it. Now for this one, y was less than that, so I want to shade below it. Now the problem with this is it shaded everything. The region, that's why you need to do this, I think, in oh wow, look at that. Let me redo. I didn't want to exit all of that. I want to see if I can take some of these out. Oh, you can plot a point anywhere. That's very nice. Can I unshade anything? But I can erase. Let's see what that does for me. Ah, there we go. There. So you kind of have to keep track of it or do it yourself on a graph paper and get the shaded region that you want. To me, it's got to be above y equals 3x plus 7, but at the same time below the dashed one, so above the solid one. So I actually have the wrong region shaded. I think it should go here. And then for this, I think it should go here. So let me check myself. I'm above the solid line, yes, but at the same time I'm below the dashed line. So we'll check ourselves. Good. And so there you go. There's how you play with things in the program. They'll have you put in your region after all is said and done. So I hope you found this video enlightening, and I hope it was worthwhile for you.